Here is the implementation part of my project, which is diabetes prediction. I imported the important libraries like pandas, numpy, matplotlib, and cbond. And the secondly, I read the my dataset, which is diabetes.csv. Then here you can see the first five entries of my dataset are here. Then the DF shape gives us the exact column and rows of which is 2000 rows and 9 columns. And here is the names of columns we have, which is pregnancies, glucose, blood pressure, etc. Because the DF info gives us the exact data type of our columns, which is int and float, basically in this. And here I checked for the missing entries, which is 0. Then I plotted the heat map graph of my dataset, and then I correlated my dataset. Then I found the unique number of each values I have in my dataset. Pregnancies has 17 different values. Glucose has 136, blood pressure is 47, skin thickness has 54, and etc. etc. It goes on. And DF describes it describes the with like 25% of pregnancies lie between 1 here, and the 25% of values of glucose lies between 99, and 50% of values lies of pregnancies lies between 3. Here it describes basically about the dataset. And here I dropped the column which I have to predict outcome. Then I imported the sklearn model selection. Sorry, import train test script for training my dataset, and I distributed in xtrain and ytrain and x test and y test. Here you can see xtrain has some entries. I have shown the first 5 entries of xtrain and xtest. And here I applied the first algorithm of my project, which is logistic regression. I imported the logistic regression from sklearn.learning model, and I applied it on the xtrain and ytrain. Here you can see. Okay, and here you can see it is implemented. And in ypred1, I predicted the first values, and here you can see the logistic regression score is 0.77, which is 77%. And this is a classification report of my first algorithm.
It shows that it has 77% accuracy here. And this is the pie chart for logistic regression. It shows that it has predicted 23% wrong prediction. Here's the confusion matrix for logistic regression. It shows that it has predicted 91 false negative values. And here is the ROC curve for logistic regression. It shows that the AUC value for logistic regression is 0.83, which is 83%. Here comes the second algorithm, which is random forest. I've imported random forest classifier from sklearn.ensemble library. Here is the classification report for random forest, and it shows that the accuracy is 95%. Here's a pie chart for random forest. It shows that it has predicted 5% wrong prediction. And here's the confusion matrix for random forest. It shows that it has 17 false negative values. And here is the ROC curve for random forest. It shows that the AUC value for random forest is 0.99, which is 99%. Here is the third algorithm, which is SVM, support vector machine. I have imported SVC from sklearn.svm library, and here is the classification report for SVM. It shows that it has 77% accuracy. Here is the pie chart for SVM. It shows that it has predicted 23% wrong. And here's the confusion matrix for SVM. It shows that it has 107 false negative values. And here's the ROC curve for SVM. It shows the AUC value for SVM is 0.70, which is 70%. Here's the fourth algorithm, which is decision tree. I've imported decision tree classifier from sklearn.tree library. Here's the classification report for decision tree. It shows that it has 96% accuracy. And here's the prediction pie chart for decision tree. It shows that it has predicted 4% wrong. And here's the confusion matrix for decision tree. It shows that it has 107 false negative. Here's the ROC curve for decision tree. It show it shows that it has 0.99 AUC value, which is 99%. Here's the bar graph for all algorithms. Here, decision tree has a maximum accuracy, which is 96%. And here comes the report line graph for logistic random forest, SVM, and decision tree. Here is the comparison of recall, which, and here is the AUC curve for all model. It shows that decision tree has the maximum value, which is 99%. And the conclusion is based on precision F1 score, recall values, prediction pie chart, accuracy score, confusion matrix, ROC curve, and AUC line graph. We can say that decision tree classification is best suited for this problem where we are predicting whether a person is suffering from diabetes or not. Thank you.